Okay, we'll continue. We had seen the basics now. We had just seen the basics of all the balanced, unbalanced systems. Okay, the figures we had seen for star and delta connections. See, this only is the figure for the unbalanced delta. Okay, the same figure. I've just written one sentence here. Figure 2 shows the unbalanced delta connected. That one also is cleared now. Next, we'll move on with some problems. So first one, a three-phase 400-volt four-wire system. So you have to read the problem clearly. A three-phase 400-volt four-wire system has a star-connected load. Okay, the load is star-connected. With they give the values ZA, ZB, and ZC. Find the line currents. You have to find the line currents, and the load is star-connected. So since it is a star connected load, you have to just first, when it is star connected load, you just write down the formulas that are used. That is line current is equal to phase current, and line voltage is equal to root 3 times phase voltage. Fine. So how much is the line voltage they have given? They have given line voltage has 400 volts. Okay, that 400 volts you have to write here. VL is 400 volts. So how much is phase voltage? Phase voltage is nothing but line voltage divided by root 3. That is 400 divided by root 3. V phase is equal to, this will go to the LHS. So we'll get 400 by root 3. So find out that value. It is 230.94 volts. Next we have to find the three phase voltages here. Okay. So you have to bring that difference in the angle, that is VAN, VBN and VCN are the three phases. With respect to neutral we are taking up. So it is 230.94 at an angle 0. Second one will be minus 120 and third is minus 240, or you can take it as plus 120 also. These are the three phase voltages. Okay, so first we found out of one phase voltage and we put the angle for it, and here the line current is same as phase current. So finding both, if you find out line current, it will be like you're finding the phase current only. So phase currents and line currents is same. So we'll go with the line currents, that is IA is equal to VAN divided by ZA. Sorry, phase currents and line currents are same. So phase voltage divided by impedance. Okay, line current is equal to voltage divided by resistance. That is the formula used. So the first one is 230.94 divided by 10 plus J. 10 plus J they have given ZA, ZB and ZC. Just substitute all the three and you'll get the angles here. That is IA, IB and IC. That is 23 at an angle 0, 12 at an angle minus 153 and 46 at an angle 30. Okay. The next we have to find out, if you want you can do this, that is the neutral current. Neutral current is nothing but the sum of the line currents, that is IA, IB and IC. Just add all the three and write the sum here. See here, the formula written is of line current only, IA, IB and IC. This line current and phase currents are same. So if you find out line current, it is like finding the phase current only. This phasor diagram, I'll just teach you on the whiteboard here. Here we have to draw VAN, VBN, VCN. Okay, then we have to put these angles IA, IB and IC. I'll just show that one problem on the whiteboard tomorrow. Okay. Next we'll go with the next problem. An unbalanced 4-wire star connected load, okay, has a balanced supply. The load impedances are, here they are given ZBN, ZAN and ZCN. Calculate line currents, neutral current and load power, that is active power. They have told you to find out the active power. So what they have given is VL is 400 volts. Find out the phase current, that is VL by root 3. You will get the, phase voltage, not phase current, phase voltage. Line current and phase voltages are equal. Find out all the three phase voltages, that is VAN, VBN, VCN. Okay, how you will find out? We got 230.94. Okay, that with an angle 0, minus 120 and minus 240. Next find out the line currents, which is same as phase current. So it is voltage divided by resistance. So 230 divided by resistance, this value you will get. Next all the three currents you find out, IA, IB and IC. We'll get the three currents. So neutral current is IA plus IB plus IC. Add that and get the neutral current. Next, with this phasor diagram, see here in this phasor diagram, we have to draw this VAN first. Okay, VAN and VBN will be at 120-degree difference. Okay, and this from VBN to VCN, just need not go with protractor and all. Approximately you can put. So VAN, VBN and VCN at 120-120-degree phase difference you have to put. Next, what you have to see? Next, you have to see this line current, that is minus 63.43. Okay, that 0.43 and all you can just neglect it. You can just take minus 63. How you will decide? See, this if I just draw the dotted points here, this is minus 90-degree. Okay, this is plus 90, this is minus 90, this is plus 180, this is minus 360. Like this it will be going. So this is 90. So minus 63 will be between this both. It will be VAN and this 90-degree, right? So you can just take an approximation of IA like this. Okay. So this angle will be minus 63.43. That is IA. Next IB. IB is 173, minus 173. See, minus 173 should be near to minus 180. This was minus 180. Okay. This angle is 120. It should be greater than 120 and less than this minus 180. So it will be between here. So it is minus 173.13. And the third angle is 86. It is plus. Okay. It is plus 86. So this is plus 90 here. Fine, this is 90. So plus 86 will be near to 90. Okay, it should be near to 90. So it will be near to 98. It is 86.36. This is how we draw the phasor diagrams. Here in phasor diagram we have to use phase voltage and phase current. Since we have the same, okay, line current and phase current are same. So we are using here line currents only. But when we go with delta, you have to find the phase current separately. That I will show you. This is how to draw the phasor diagram. Next, we have to find out what? Next, we have to go with finding out the power. Okay, we have to find out the power. So we have to write the equation for power. So power is equal to for all the three you have to write a VAN IA. Okay. Next VBN IB. And next is VCN IC. This is the voltage and current, voltage and current, voltage and current. Next, we have to find out the cos of the angle because it is active power. Cos of VAN and IA. Okay, VAN and IA. What is the angle? This is the angle symbol. Next is cos of VBN angle IB. Next is cos of VCN angle IC. All the three angles you have to write. Next, we have to find out. How much is VAN? We had calculated. How much is VAN? VAN is 230.94 at an angle 0. That I have written here. 230.94. This is VAN. How much is IA? IA is 25.81 at an angle minus 63.43. That is written here. 25.81 at an angle minus 63.83. Okay. With that, you have to find out the cos of the angle between VAN and IA. How much is the angle between VAN and IA? It is nothing but minus 63.43. You have to find the cos of it. Okay. After finding the cos of it, you have to write it here. Next, the same thing you have to do for VBN, IBN and cos of the angle. Getting it? See here. Once again, I'll show you. This is VAN, this is IA, this is cos of the angle between VAN and IA. It is minus 63. Next, angle between VBN and IB. See, VBN is here, IB is here. Okay. VBN from here to here it is how much? It is 120 degree. From here to here it is minus 173. So minus 173 minus of minus 120 you will get 53. Okay, in that way you have to calculate and it is written the angle between VBN and IB is minus 53. That angle I have written here, minus 53. Okay, this is how you have to find the angle between the voltage and current, and that should be substituted. You have to find the cause of it and get the answer. So the total active power will be 11.5 kilowatt. This is the formula used and substituted. Next, determine the line current in the unbalanced star connected load supplied from a three-phase 440 system. The branch impedances they have given. Draw the phasor diagram and calculate the active power. Same thing. The only difference it is 440. Okay, 440. Go with the same steps. Find out the phase voltages, find out the phase current, same as line current. Next, draw the phasor diagram. Phasor diagram VAN, VBN and VCN. Next is IA. IA is how much? Minus 30. So it should be between this 90 degree and this 0 degree. Okay, minus 30 will come here. Next, going on to find out the angle. The angle between VAN and IA is minus 30, that is written. Between VBN and IB. See, VBN and IB. IB is at 165. It is at 120. Minus 120 and 165 will get it as minus 45. That is written here. Okay, that is the angle that is shown here. That way you have to calculate and you have to find out the power. One more thing, VAN and we have written here this IA only magnitude we are writing. We are not writing the angle here. We are writing only 63.25. That is the IA current. Okay, 63.50. Next, we'll go with this unbalanced delta connected load. In unbalanced delta connected load, the phase voltage are same as line voltages. That is the first point. The phase currents are obtained by dividing the phase voltage by respective phase impedances. From the phase currents, line currents are obtained by using the equation. Okay. So we'll just see one example of delta also. A three-phase supply line voltage of 250 volts has an unbalanced delta connected load. Okay, and the determine line current and total active and reactive power if the phase sequence is A, B, C. You have to go in that sequence only, what sequence they give. So this is the figure they have given. So all are different. One is 25 at an angle 90, one is 20 at an angle 0, one more is 15 at an angle 20 degree. This is IA, IB and IC. In delta connection, line current is equal to phase current. So both if it is they have given 250 volts, it will come for both line and phase. So I have written as 250. And phase voltages will be 250 at an angle 0, 250 at an angle minus 120 and 250 at an angle minus 240. See here, to find out the phase currents, it's nothing but phase voltage divided by impedance. Just draw the phase voltage divided by impedance, you will get phase currents. To find out the line currents, okay, you have to use the formula IA is equal to, we have to go in that sequence, IAB minus ICA. See, AB after BC, then after CA. That sequence should be followed. IAB minus ICA. We know IAB and ICA, just substitute, you'll get the answer. Okay. Next, if you want IB, it should start from B. After B, next is C. BC. After C, next is A. BC, AB. In that sequence only you have to go. Okay. Next, IC. Both we have to find separately here. Line currents and phase currents should be found separately because they differ in delta connection. And in phasor diagram, you have to draw phase voltage and phase current. You should not use line currents. You have to draw phase voltage and phase current. After drawing, you have to go with this total active power. Fine. In total active power, just write the formula VAB, IAB. You have to find the cos of the angle. See here, cos of the angle between VAB and IB is how much? It is minus 90. Here it is. What is VAB? VAB is 250. We found out. What is IAB? IAB is 10 here. That is written here. VAB is 250. IAB is 10 and cos of the angle. Next, cos of the angle between VBC and IBC. See here, VBC and IBC. How much is this angle? VBC and IBC. Till here it is 120. This much is 120 degree, right? From here to here, how much they have taken? It is plus What is the angle that is there? I think it is minus 140. Okay, it should be just little more than 120 here. Till from here to here it is minus 140. So this is 120. So what will be the difference? Minus 120 and minus of minus will become plus. So this will become 20. So that is the angle. Okay. Just write that the same equation, only you have to find out the sign of the angle here. Here we are finding cos for active power, and for reactive power just find out the sign of the angle. Here it is kilowatt and here it is VAR, volt ampere reactive. This is how the problem is done for the delta connections. So we have seen the examples for star and delta connections. So we'll continue. Thank you.